Hi everyone, this is Mr. Chang, and in this video, we're going to continue looking at turtle robots, and we'll also take a look at a while loop that counts up. So in the previous lesson, we learned about while loops. And when you're using loops, kind of think to yourself these important questions. Should the statement be inside the loop or outside of the loop? For example, do you want the statement repeated? If it's outside of the loop, should the statement come before the loop starts or after the loop ends? Now let's go ahead and create a script under Workplace, and a script will execute when your game is played. So let's go back into Studio here. And again, I'm just going to go ahead and just add a script like so. Now we're going to use Instance.new. Instance is the base class for all classes in the Roblox hierarchy. Instance has a special function called Instance.new, which is used to create objects via code. So instead of adding parts manually and then customizing them as we have in previous lessons, we'll use Instance.new to create them. So let's go ahead and inside of Studio, we are going to have local part equal Instance.new part. And let's call this our turtle. And let's parent that to our workspace. And let's create a new shape here. And let's make our shape a ball. And very specifically, we are going to make a green ball. So let's make it size of 2. And we're going to change the brick color to brick color equal brick color dot new dark green. And let's put the starting position as the same position as our spawn location. And let's also anchor it at the same time. All right, so let's go ahead and test this and make sure that our ball is ending up in the same spots. And looks like we did not put it in the right spot. Let's try this again here. So we've got position. And I forgot the new word there. Tiny oof. So let's try this again. All right, so here we go. So again, this is the exact same position as our spawn location. And so again, we are going to we're going to try to go from this way, and then we're going to try to go this way with our green ball, which is acting as our turtle. Now, to go forward, what we're going to do is we're going to add 4 studs to the Vector3 Z value. And to see the ball move, we're going to add a wait of 2 seconds. Now, if we don't add the wait of 2 seconds, the ball's just going to move so fast that we actually won't really see it move. So we're going to purposely wait 2 seconds in every movement. So let's go ahead and try this out here. So we've got wait 2, and we're going to move our position here, and we're going to say part position, and we're going to add 3, Vector3, and we're going to add 4 studs there. All right, so let's give that a try. And again, we've now gone 1 space here. Okay, and if we think about it, we do need to go 4 more here. So to go 4 more, what we can very easily do is just add the same code 4 more times. So let's go ahead and add this. We have 1, 2, 3, 4, 5. And let's go ahead and run this code here and watch our turtle move across here. So we've got 1, 2, 3, and then we've got 4 over there, which is great. All right. So we've now got our turtle moving 5 spaces going forward. However, when coding, whenever you find yourself repeating yourself, you just think to yourself that there's probably a better way to do this. So let's use a while loop that repeats 5 times. That way we won't have to duplicate our code as we just did. So to use a while loop like this, we're going to do something a little bit different than we did with the while true loop. We're going to use a stepper variable, and the stepper variable pattern is as follows. So we're going to initialize the stepper variable. Typically, you'll initialize that to either 0 or 1. Then we're going to increment or decrement the stepper inside of the while loop. So let's go ahead and try that here. Now, first off, we're going to define the stepper variable. Again, we're going to start counting with 1. So let's go ahead and inside of our code, we're going to initialize our stepper variable. We're going to say local x equal to 1. Now, just kind of recall the structure of a conditional in Lua. We had, let's say, if x less than or equal to 5, then we did something inside of the then and the end over here. Now with the while loop, we looked at the while true, and while the condition was true, and we had our infinite loops in the last lesson, it would just execute the code between do and end. So now we're going to do something a little different. We're going to have our while x less than or equal to 5. And then at the very end of our while loop, we're going to add our x equal to x plus 1. And that's going to change the value of x inside of the loop. So it changes and it loops 5 times. Now, if we happen to not include this line over here, we would actually end up with what we had in the previous lesson, which is an infinite loop. So just kind of note that there. And again, typically you want to add this particular line of code, changing the value of the stepper variable at the very end of the loop. All right, so let's go ahead and go back to our code here. And we're going to have our condition here. So we have x less than or equal to 5. We have do. And this is the code that we are going to repeat. We can actually get rid of that code now. And the last line of code we need, again, is our stepper incrementing like this. So let's go ahead and see if this works. So we've got 1, 2, 3, 4, and then 5, which is great. Now, let's go ahead and look a little closer at our stepper variable as it changed with every iteration inside of the loop. So to do that, we're going to trace through it and kind of like do this by hand here. So here in the first iteration, because we initialized our x to 1, which is right up here, we have x equal to 1. We have 1. The condition here would be 1 less than or equal to 5. So the condition there is true. And then at the very end of the loop, we are incrementing the x. So x becomes 1 plus 1, which is 2. Now, in the second iteration, again, we have our 2 here. And then we have our condition, which would be 2 less than or equal to 5. 2 less than or equal to 5 is true. So we would keep going. And then we would go over here. We would have our x equal to x plus 1. So that's 3. 3 would go over here. Then we have 3 less than or equal to 5. 3 less than or equal to 5 is also true. And so now we have this again. So 3 plus 1 is 4. We have 4 over here. Now we have 4 less than or equal to 5. That is true. And then again, we have over here x equal to x plus 1, which is 5. 5 comes down here. Condition is 5 less than or equal to 5, which is True. Now we go over here again. And so now our 5 becomes 6. So now we've got 6. And now we've got 6 less than or equal to 5, which is finally false. And that is where our loop finally ends. All right. So the next step here is that we have to move the ball in a different direction in order to get to our final destination, which is over to the right. So to do that, again, we're going to use the popular stepper variable I this time, and we're going to increment in the x direction this time. So again, vector3 new goes x, y, and then z. So let's go ahead and give that a try here. So again, I'm going to initialize our stepper variable. This time I is equal to 1. And now we have while I less than or equal to 5. We're going to wait 2 seconds again. And then we have part position equal part position plus vector3.new. And again, this time around, we are going to actually decrement our x value over here. This happens to be going down because we are going to the right. And now let's go ahead and increment our I. So let's give that a try here. And let's watch as our ball moves over. So we got 2, 3, 4, and then 5. And then we turned it. So now we're going the x direction. We go 1, 2, 3, 4, and then 5. All right. So again, you're going to see variations of this on the AP exam. This is classical computer science using the turtle. All right. I hope this helps, and I'll see you in the next video.